Ethanol fermentation.
For materials, we used a 2-gallon bucket, a lid, 4 packets of active dry yeast, a balloon and some PVC, 5 pounds of sugar, 2 gallons of distilled water, a hot glue gun, and a 1/2-inch tube.
First, we began cutting a hole into the lid. Next, we put a balloon on top of a small PVC pipe. Next, we put into the hole we made.
We took our 2 gallons of distilled water, 5 pounds of sugar, and put it into a 2-gallon bucket. Then we mixed it up. Then we put in the 4 packets of yeast. We mixed it up again. As we were mixing, we began to notice CO2 bubbles forming.
Next, we placed the lid on top of the bucket. 2 hours later, we noticed the balloon grew with CO2.
However, the tension of the balloon was too much for the bucket lid. So we made a makeshift fermentation lock out of a tube, the jar with water in it. That way the CO2 can escape in the form of bubbles, but air will not be let in. If air was to be let in, the mixture would oxidize, which would ruin the experiment.
Next, we tested to see if it was producing CO2. This is the control group. As you can see, the CO2 levels are very low. This is the experimental group. The tube is allowing CO2 to enter the chamber. As you can see, the CO2 levels are rising.
Unfortunately, the CO2 meter was only set to have a maximum of 10,000 ppm. We noticed the switch on the side of the CO2 meter that could switch between 10,000 and 100,000 ppm. We switched it to the 100,000 ppm and redid the experimental group.
After a week of fermenting, we opened the lid and noticed it was bubbling. We made the hole through the 5-gallon bucket and put a tube through it. We glued it in a spiral fashion to the sides of the bucket.
Ethanol distillation, trial 1. We set up this part of the experiment with a hot plate with a flask on top, a PVC pipe running out of it with a thermometer in it, a tube running out into a bucket full of water where the ethanol gas will be condensed. We put a beaker under the tube where the ethanol will be collected. We put aluminum foil around the flask to make boiling faster and ice in the bucket to make condensation faster. After a few minutes, the mixture is boiling and condensation is happening in the tube. As you can see, the temperature is 88 degrees Celsius, which is the exact temperature that we want because ethanol boils at 78 degrees and water boils at 100 degrees. We only want the ethanol to boil because we want to separate the ethanol from the rest of the mixture. The ethanol is dripping into the beaker. Unfortunately, the thermometer was too far away from the liquid to get an accurate reading, so we accidentally made it too hot, and the water was boiling too. This diluted the ethanol. We decided that we had to do the experiment again the next day. Ethanol distillation, trial 2. This time, we drilled a hole directly in the clay connector. This way, the temperature probe is directly in the liquid. You can see the ethanol gas going down the tube. Time for the burn test. Yes! It's ethanol!
We tested the density of ethanol and compared it to water.
These numbers are very close to what they are supposed to be. That means this mixture is primarily ethanol. Since yeast made CO2 and ethanol from sugar, that means our hypothesis is correct! Yes!